Okay, let's dive right into this explainer, because the story of AI has pretty much been the story of NVIDIA for years now. They built an absolute empire, supplying the chips that power the AI revolution. But right now, we are witnessing a massive structural shift in the hardware landscape as we head into 2026. We're talking about an explosive rise in custom silicon that is completely reshaping who actually holds the power in tech. Get a load of this number: 60%. Despite NVIDIA's frankly unassailable success and tens of billions in data center revenue, a staggering 60% of that money relies on just a handful of hyperscale cloud providers. We're talking the absolute heavyweights: Google, Amazon, Microsoft, and Meta. They are the engine keeping NVIDIA's current profitability running at hyperspeed. But having all your eggs in just a few massive baskets creates a pretty wild situation. It's what we call the insourcing paradox. NVIDIA's absolute largest, most lucrative customers are actively, and I mean aggressively, transitioning into their fiercest competitors. Instead of just buying chips off the shelf, these hyperscalers realize they have the massive capital to design their own hardware in-house. So they are literally funding the research to replace the very vendor they currently rely on. Section 1. The hyperscaler imperative. We're going to look at cost, control, and customization. So why take on the absolute headache of building silicon from scratch? Well, it boils down to three strategic imperatives. First up, slashing operational expenses. Running these massive AI workloads on third-party hardware incurs huge recurring costs. If you operate at the scale of a Meta or Google, shaving off even a fraction of a cent on computation saves you billions. Second, full-stack optimization. Custom chips give hyperscalers total control over the hardware and software, letting them perfectly tailor the silicon to their own proprietary AI models. And third, supply chain resilience. No one wants their entire business relying on a single vendor, especially when global chip shortages are a real threat. And this is a perfect way to visualize the technical shift. On one side, you've got general-purpose GPUs, like NVIDIA's. Think of them like the ultimate Swiss Army knife. Incredibly capable, they can handle almost any parallel task you throw at them, but they use a ton of power. On the flip side, you have custom ASICs, or application-specific integrated circuits. These are like a scalpel. They aren't great at everything, but they are masterfully honed for one specific, highly efficient AI operation. For a cloud giant running the exact same AI model millions of times a second, they don't need the Swiss Army knife. They desperately need the scalpel. Section 2. Who is building what? Let's run through the custom silicon roll call. Look at this lineup. Every major player is in the game now. Google pioneered this with their tensor processing units, or TPUs, and they've scaled so well that Anthropic is committing to deploy up to 1 million of them. AWS has a great dual strategy going with Trainium for training and Inferentia for efficient inference. Microsoft's Maya is already proven at the absolute frontier scale. They're running GPT 5.2 workloads natively on it, alongside their Cobalt CPUs for general processing. Then you have Meta using their MTIA for social media algorithms. And get this, even OpenAI is stepping into the ring with Chalapanya, a custom chip designed to bypass the steep costs of NVIDIA setups for large language models. Now, make no mistake, these are not just experimental little side projects. When you look at the sheer volume of capital spending on this chart, tech giants are pouring billions into this proprietary infrastructure. They are playing the long game here, investing massive amounts upfront to permanently alter their unit economics down the road. Moving to Section 3, the fabless supply chain. Let's talk about how software companies actually build physical chips. Now, you might be wondering, how do software companies actually manufacture physical semiconductor chips? Well, spoiler alert, they don't. They use what is called the fabless model. This means the hyperscalers basically act as the architects. They map out the logic, they handle the blueprints, but they completely outsource the actual physical fabrication of the silicon to a third-party foundry. And they aren't drawing up these blueprints entirely alone either. They co-develop these architectures with dedicated ASIC design enablers. Broadcom is the absolute giant here, partnering with Google, Meta, and OpenAI. Broadcom is literally sitting on a mind-blowing $73 billion AI backlog just by riding this insourcing trend. Then you have Marvell Technology playing a very similar role, partnering deeply with AWS's Annapurna Labs. But here is the kicker. Once those blueprints are finished, almost all of these designs share the exact same destination, TSMC in Taiwan. It's wild to think about, but TSMC is the undisputed monopoly of physical manufacturing. They control around 90% of the leading-edge logic fabrication market. So whether it's an NVIDIA GPU, a Google TPU, or a Microsoft Maya chip, they all rely on TSMC's advanced nodes and their CoWoS packaging technology to actually become a physical reality. Section 4. The new AI market, and the impact of workload segmentation. So, what does this all mean for the broader market? Well, custom ASIC shipments are accelerating like a freight train. Just look at this growth. Custom ASICs are projected to grow by 44.6% this year. That nearly triples the 16.1% growth rate of traditional merchant GPUs like the ones NVIDIA sells. The momentum is just heavily shifting towards specialized, in-house silicon. And because of that rapid expansion, custom chips are on track to account for nearly 28% of all accelerator server shipments in 2026. This definitively proves that these hyperscaler initiatives are not just some theoretical, far-off risk. They represent the absolute fastest-growing and most direct competitive threat to NVIDIA's historical dominance. Now, obviously, NVIDIA isn't exactly asleep at the wheel here. They are aggressively defending their turf with an incredibly deep moat. First, they have extreme hardware co-design, integrating GPUs with insanely fast networking, like NVLink, which is super hard to replicate at scale. Second, the CUDA software ecosystem. With over 7.5 million developers locked into CUDA, migrating to a custom ASIC means rewriting massive amounts of code, which is incredibly painful. And finally, NVIDIA is actively hunting for new buyers, targeting sovereign AI programs and huge enterprises, making sure that if hyperscalers step back, someone else is stepping in to buy. So what should you really take away from this explainer? It leaves us with a lingering, totally fascinating question. NVIDIA has built one of the strongest technological and software moats we have ever seen. But in a world where your absolute most lucrative clients, the exact ones driving 60% of your revenue, are actively engineering your replacement, what does the future of AI hardware actually look like? The chip war of 2026 isn't just company versus company anymore. It is a clash of entirely different business models. Definitely keep your eyes on the silicon because that is exactly where the future is being written.